welcome to this video. I wanted to introduce you to my active rectified alternator. So I made this one a couple of years ago and then I tested it. The reason why I wanted to make it is because I couldn't find any information about actively rectified alternators. So I wanted to make this one, design it, build it and test it as well. So basically this is a standard Bosch alternator, 100 amps. I bought it from a scrapyard and then I cleaned it up. And I tested it with the diode bridge, a traditional rectifier. And then I replaced it with my active rectifier and tested it as well. And I made a comparison between them. But let me explain first what active rectification is. So I'm going to start explaining the behavior of an ideal diode that, well, I guess you know it. So basically, when the voltage is reversed, this is the voltage in the cathode is higher than the voltage in the anode. It doesn't let the current go through. And when the voltage in the anode is higher than the voltage in the cathode, it lets all the current go through. So there is not a drop of voltage in the diode. And then we have the real diode. So the real diode, this one is like a commercial one that you can use as normal rectifier. It has a forward voltage. So for a silicon diode, it will be 0.7 volts. But for a high power diode like the ones we use in rectifiers for alternators, it is about 1.2 volts. So as you can see in this example, for instance, for 100 amps current, the forward voltage will be about 1.2 volts. That makes the power dissipated in the diode is about 120 watts. So as you know, in a bridge rectifier there are two diodes working at the same time. That will be 240 watts dissipated, and that's why the bridge rectifier in an alternator it needs a heatsink. And then we have the MOSFET. Then the important feature in a MOSFET is the on resistance. So basically, when the voltage between gate and source is 15 volts, is fully activated, the on resistance is really low. In some MOSFET, not in all of them, but in the special ones that you need for this application, the resistance can be less than 1 milliohm. That's really low. So for this example, if the resistance is 1 milliohm for 100 amps current, the drop of voltage will be 0.1 volt and the power dissipated will be 10 watts. So using two MOSFET as two rectifiers will be a power dissipated of 20 watts in total, what is much less than in the bridge rectifier with diodes that will be 240 watts. So this will be a comparison between the ideal diode that you can see in blue, the real diode that you can see in black, and the MOSFET that you can see in green. And the red square is the range where the MOSFET works better than the real diode. So for these MOSFETs that are really low on resistance, this red square can be about 300 amps, 400 amps, something like that, to be the same performance as the real diode. So the first thing you need to do is to check which on resistance you need in your MOSFET to be better than a real diode. And here you can see this is the schematic of a diode bridge in an alternator. The alternator basically are 3 coils, and each one the output will be one phase. So there are 3 phases rectified by 6 diodes, and that goes to the battery. So here we have the 3 signals of the 3 phases, 120 degrees dephased, And then below in black you can see the shape of the signal that is fully rectified. And this circuit will be the equivalent of a bridge rectifier but using MOSFETs. So you can see the MOSFETs replacing the diodes, and as well the activation circuits that will be detecting which phase have to be, or which MOSFET has to be turned on depending on which phase is higher than the other. And now let's talk about the test, how I set up the test. So basically what I did, I bought another alternator like this one and I transformed it into a motor, and then I connected them by the shaft. So I measured revolutions with a rev meter and also current using a current clamp and the battery voltage. So what I did, I was using the battery to power the motor. With the motor was moving the alternator, and from the alternator was charging the battery. And using a speed controller, what I did, I was revving up the motor, and then I could see the amount of current that the alternator was generating depending on the revolutions. So what the results, what I've got are these ones. This first chart is the temperature test. So what I did, I ran the system for 30 minutes with both rectifiers. And as you can see, the standard diodes rectifier was higher than 65 degrees, slightly higher than 65 degrees after 30 minutes. And the active rectifier, that is the blue line, was slightly below 50 degrees. So the difference of temperature in those 30 minutes was 15 degrees, but it's not bad at all. This temperature was measured on top of the alternator. The next chart is the performance, the current versus revolutions per minute. So as you can see, the blue line is the active rectifier. So it starts generating current from 900 revs per minute, and the standard rectifier starts generating from 1100 revs. That is the red line. As you can see, when they reach 50 amps, and when they reach 50 amps, you can see the active rectifier needs less revolutions per minute than the standard one. But someone might say, well, okay, yeah, but this doesn't mean anything. Maybe they are taking the energy from the motor in a different way. And then for that, I did this power delivery test as well. For this test, I was running it for 60 minutes. So I was running it from a power supply. So the power that motor was taking for the power supply was constant, and the battery was flat. I was leaving it at the minimum voltage to consider it flat. So after 60 minutes, you can see the power delivered by the active rectifier is the brown line, was 325 watts hour, and the blue line, that is the standard rectifier, was 175 watts per hour. So the active rectifier was delivering almost the double of power for the same power input. This means directly that it takes less energy from the motor, and that energy is coming from the fuel, from the petrol. Now let's talk about the advantages and disadvantages of the active rectifier. So the main advantage will be less heat dissipation. So all the components, not only in the alternator, also in the components that are around the alternator, will run cooler. And the second advantage will be more efficiency. So that means less fuel consumption in cars. This is really important nowadays, especially. And the main disadvantage will be because the components that are the MOSFET and all the logic to control the active rectifier are more expensive than just diodes. Well, this is all from my side. I hope you have enjoyed the video. If you want to make any question of the alternator, feel free to do it. Don't forget to click on the like. Thanks.